Welcome to 13.5, Reflections in the Coordinate Plane. So let's review translation. That's triangle ABC is translated 9 units right and 2 units down. You pick any of the vertices, 3, 4, 5, 6, 7, 8, 9, 9 units right and 2 units down, 1, 2. So C prime would be right there. We would write C prime at 4, 0. Do the rest of them. So 9 units right. Now, notice B is in the middle there. And look, what's its coordinate? Negative 6.5. Right, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to end up right there, 2 units down. We also notice that this has to be congruent. So the base is 3, and we should have a congruent shape here. You also want to do this in pencil, so all these markings go away. There's B prime and C prime and A prime. So 9 units right, add 9 to the x coordinate, and 2 units down, subtract 2 from the y coordinate, and we get 1, 0. We get 2.5. Yeah, negative 6.5 plus 9, right, is positive 2.5 because negative 7 plus 9 is 2. Yeah, so you can't do that because this part is also negative, just so you know why that's working out that way. Negative 6 plus 9 is positive 3, but that's negative 0.5. That's not positive 0.5. And so it's 3 plus negative 0.5 is positive 2.5. And so that's positive 2.5, and 6 minus 2 is 4. Okay, so that was translation. All right, so what we're going to do today is reflection. So when we reflect something like a mirror image, right, we reflected this across the x-axis. When you reflect something, you've got to state what you're reflecting it across. What's the mirror, the physical mirror? And one way to think of it is more like flipping a pancake. Like you took this heart and we flipped it over here, okay, across the x-axis. We'll also be flipping things or reflecting them across the y-axis, and they would end up over there. So let's reflect our first object, F, across the y-axis. Now, the key to this is that the image, it's called, is the same exact distance away from what you're flipping it across. So it says across the y-axis. It doesn't have to be the closest one. I could be going down here. So we're flipping across the y-axis. So this side here has to be congruent, and it has to be the exact same distance away. So that means this point or vertice over here is at 6, so it better be at negative 6 over here. And so here's our new object, and we still call it F prime. And it should be congruent, although mine looks a little thicker. Let's skinny it up. There you go. And so we have reflected our first object across the y-axis. So now reflect F across the x-axis, remembering it has to be the same distance away from the x-axis as what we started with. So we're here at, this edge is at 5, so it's got to be down here at negative 5, and it's got a line right up with it. Right? This has got to be right on, oops, I'm missing, on top of that one at 6, and this one has to be at 1. And this one's at 7, so this one will be at negative 7. And don't twist it or anything, it's a flip, all right? A reflection. And so we'll label this all, right? We're going to also, we can call this, no, we're going to call, we can call this F prime as well. All right, so we're going to reflect J across the x-axis. Pause and do that. So we're going across the x-axis. You've got to read this, right? It might be tempting to go here, but that's across the y-axis. So this is at -4, +4. This is at -8, +8. And you draw a congruent shape up there, and that's our J prime. So what's the pattern with the numbers, right? When we were translating, we were adding and subtracting from the coordinates. Well, when you reflect an object across x, x stays the same, y becomes its opposite. So let's reflect KLM here. So we're at 3, -3, right? We're flipping or reflecting it. This is at 6, so we're down at -6. So this is L prime, M prime, and K prime. Now we could read the coordinates right off of the graph, but let's use the pattern. So K prime, X should have stayed the same, and Y should have become its opposite, right? 4, -6. L prime, X should have stayed the same, and Y should have become its opposite. And similarly, M prime, X should have stayed the same, and Y should have become its opposite. Okay, that's the pattern when you flip across X. So hopefully you can guess what the pattern will be when you flip across Y. Oh, but we're not there yet. So to reflect a function over the x-axis, we're multiplying by -1. We talked about this when we did quadratic functions, right? That first coefficient must be negative. Right, so this is x squared plus 3. So let's write g of x. And it says reflect the function over the x-axis and write the equation of g of x. So what you have to do is multiply everything by -1. So do that. So it would be -x squared minus 3. So let's draw that. So we have, see, this has a y-intercept of +3. The g of x has a y-intercept of -3. And it literally will be a reflection. So this one's at 4, so we're down at -4. This one's up at 7, and we're down at -7. And that's how you reflect a function, any function, in the coordinate plane. To reflect over x, you just multiply by -1. All right, so there's that absolute value function again. All right, and we're going to reflect this. Notice it's already, right, it's got that negative coefficient there, -1. And we're going to flip it over the x-axis. So now we've got to multiply everything by -1, right? Both. And so g of x here is absolute value of x. -1 times -1 is +1. -1 times +2, right? And every point here will flip over the x-axis. And you'll get another V shape, right? That was awfully sloppy. Let's be a little neater. Right? Maybe I should use a straight edge, and maybe you should too. And so we have reflected that over the x-axis. It's a mirror image. All right, so finally, we're going to be multiplying over the y-axis, or flipping over the y-axis. And so there's the y-axis, right? And what's the pattern? Y will stay the same, and x will become its opposite. So let's draw it first. So this is k prime. Now notice, this is L prime, right? Because it's flipped. And this is M prime. So you reflect something over the y-axis, the x coordinate becomes its opposite. The y coordinate stays the same. So k, well, I should have written k prime in there. K prime should be at -4, +6. It is. So L prime should be at -2, +3, and M prime should be at -6, +3, right? So triangle NOP is reflected across the y-axis. So we're going over here. Find the coordinates of the new vertices, okay? So if reflecting across y, the y coordinate stays the same. The x coordinate becomes its opposite. So n prime should be at 4, -1. X coordinate becomes the opposite. Y coordinate stays the same. O prime should be at 3, -6. And P prime, and I should be writing N prime and O prime and P prime in there. And so it's 5, -6. And so we label N prime, right? This one is O prime. The one farther away is now P prime because we've reflected or flipped it across the y-axis. All right, so now we are going to combine translation and reflection in the same picture. Oh, and reflections across the y-axis for functions is going to be high school. So we're going to skip that. All right, so translations and reflections are both types of transformations. We're actually going to learn 4 types of transformations in this unit. So we've learned 2, translation and reflection. So this says define each transformation as a translation or a reflection or a combination of the 2. So let's see that. So how did we get from S to T? Well, it's facing the same way. So it wasn't flipped. It wasn't reflected. It was translated. And how much was it translated? Well, we went from -2 to +6 for this corner right here. So, and if that corner went from, 8 spaces to the right, every single point on the object went 8 spaces to the right. So we're going to say translated, or we're going to say translation 8 to the right. All right, so that's how we do these. So try to do S to V. S to V. Now it's been flipped, right? It's not facing the same way. So it's been reflected. So it's a reflection. Now you got to say which one across the x-axis. The x-axis. V to U. Well, V to U, it's clearly reflected, but let's write that. There is, oops, I didn't spell reflection in the last one correctly. It's clearly a reflection across the y-axis. But it's also something else, because if you just reflected it, all right, it would still be there, right? This was a combination, right? When you do a reflection, the new object ends up the same distance from the reflection border as the original object. So we also then moved it, there was also a translation 2 to the right. Now notice, that is not the only correct answer. The other way it could have been done, you could have translated this 2 to the left. You could have gone this way and then reflected it. So there's going to be more than one answer for the ones that have a combination, usually. All right, so let's practice. Reflect G across the y-axis. Are the areas congruent? Are the same amount of squares in both shapes? Yes. In fact, translations and reflections always result in congruent objects. That means they have the same perimeter, same area, the same lengths, same angles. Everything's the same. Now find the area. Oh my goodness. What is that? That is a trapezoid. Okay, so how do we remember how to find the area of a trapezoid? The area of a trapezoid is 1/2 times the sum of the two bases, base 1 and base 2, times the height. Similar to a triangle, right? A triangle is 1/2 base times height, but a trapezoid has two bases. It's the two parallel sides. It's those two sides. So this is 1/2. One of the bases is 2, the other base is 4, and the height is the distance between the two bases. So which is 3 here. Or did I draw this other one too big? Yes, I did. I did. So it goes right there. And so the height here is 3. And so 2 plus 4 is 6. Half of 6 is 3. And 3 times 3 is 9. And this is an area, 9 square units. Now, so let's count some boxes, right? 9 square units is the number of squares that are there. Let's see if that makes sense. 1, 2, 3, 4, 5. There are 6 whole ones. And the question really is, do these little bits, well, those two seem to add up. Do these two, right? These two add up to close to 1, it seems like. So that'd be a 7th. These two add up to 1, that's an 8th. And these two look similar to maybe a half. They're a little off. This is not exact by any means, but it is, well, let me say this. It is exactly 9 square units. But those little fractions, not necessarily half a square. So you'd have to add all the fractions to see exactly that it's 9 square units. All right, so we're going to do whether this is a translation, reflection, or a combination. So by the way, this shape is called a what? It's called a parallelogram. Right? In a parallelogram, both sets of sides are parallel. A rectangle is a parallelogram. I didn't draw a very good one. It's just a special one. A parallelogram, the opposite sides are parallel. A trapezoid is not a parallelogram because these two sides are parallel, but these two other sides are not. So this is a parallelogram, and from A to B, well, it seems like it's facing the same way. So there's no reflection here. 1, 2, 3, 4, 5, 6, 7, 8. I think I went from -4 to +4, so I went 8 units right. And then get 1, 2, 3, 4, and 5 units up. Oh, and I've forgotten one thing. This is a translation. I have to write that. So it's a translation, 8 units right and 5 units up. Boy, I'm going too fast. I'm misspelling things. And you can do that in any order, right? You could have gone 1, 2, 3, 4, 5 to the up, and then 8 units right. All right, B, oh, I left lots of room. B to C, okay. So how do you get from B to C? Well, they're no longer facing the same way. So I think there's a reflection involved. Are they the exact same distance from the x-axis? Yeah, they are. This one's at 9 there. This is at -9. They're congruent, but flipped over. This is a reflection across the x-axis. Always say what it's across. All right, D to C. So D to C. Well, they're not facing the same way, so there's a reflection involved. And so let's say there was a reflection across the y-axis. But if I reflect D across the y-axis, I'd be over here at 4, right? I'd be over there. So this must be a combination. So I reflection across the y-axis, then I went 1, 2, 3, so a translation 3 units left. That is not the only way you could get there, right? You could also get there by translating 3 units right. If you put 3 units right first and then reflect across the y-axis, you would also get there. So there's 2 answers to this, which is typical. So there's a quadratic function. We're going to reflect that over the x-axis. So we're going to multiply everything here by -1. And we get g of x equals x squared plus 2. But now, instead of having a y-intercept at -2, it has a y-intercept of +2. Everything is the same distance away from the x-axis. We're not going to do any functions across the y-axis this year. Everything remains symmetrical. And that's our quadratic function reflected across the x-axis.